Hello everyone and welcome to Google Cloud OnBoard. My name is Ify and I'm an instructor for Google Cloud. Today we'll be talking about big data and machine learnings. So at any time during our live sessions, you can ask questions on our platform and our team is standing by to answer them. So let's check the agenda first. So what we're going to talk about here, the first module will about the Google Cloud Platform itself. Although we actually mentioned something about like infrastructure stuff, compute, network, those kind of things. But from a standpoint of data, when we deal with data, yes, we need to know something more. So we'll talk about that. And then module 2, we'll talk about recommendations, predictions. Then we'll have a short break, which is you have some coffee with you maybe right now, and you're going to just stay there and then have a little bit of coffee, and then my time for the coffee as well. And then we move on to module 3, which is real-time dashboard. That'll be something really, really amazing. And then I got amazed, and then I'm going to show you how cool it is. And then module 4, we'll talk about some driving insights with machine learning. And that one is just fantastic. And I really love it when I learn, and I'm going to show you. So let's get started. So the module 1, going to introduce about our Google Cloud platforms. So, I mean, you guys are here, you're of course more like into the data stuff, or even you just want coming for the machine learnings. It's okay. Then since you guys are here, you know that now it's an explosion of data kind of generations. So here is a statement coming from McKinsey. They said by 2020, some 50 billion smart devices will be connected along the additional billions of smart sensors, ensuring that the global supply of data will continue to move more than double every 2 years. Wow, that's a lot. So that means by 2022, we will have 100 billion. Wow, that's a lot. Okay, so at the same time, interestingly, we only have roughly 1% of the data which is generated that we actually analyze today. I mean, I think for you and even for myself, when we look at this kind of statement, we kind of feel, interesting. We have so much data. I mean, how come we don't really analyze them? Is it like there's no value in it? I don't think so. I kind of believe every single data, there's a meaningful there. Even there's a log. I mean, that's good for us to know what's the status, what's the kind of user behavior, that kind of things, right? But I would say the reason why such a small amount of number actually get analyzed is just because we don't get the chance, or we don't have the kind of tool or service to support us to taking care of that. So let's see. So we're actually going to focus on the data engineering role here for all the kind of stuff. I mean, there's a lot of different roles that you can actually work in a data team. For example, you can be the analytics, you can be the applied ML engineers, or you can just be the decision makers. But I mean, while we're trying to focus here, I mean, we are cloud, we provide you tools, we provide you frameworks. So we wanted to more focus on this one, to make things really happen. Because I'll say, like a data scientist or applied ML engineers, yes, engineers will be the people to make things really happen. So I'll say those people to make productions. And of course, now we do want you to help with that. And that's what we're going to focus here. So what are those challenges as a data engineer? And then we have some ways to help you. So first one is migrate some existing data workload. For example, you have some Hadoop, you have some Spark, you have some different kind of framework that you're running on Prime or on different kind of places. And I'll say you do have some migration kind of challenge. Why is that? Pretty simple. You kind of believe, oh, come on, I have my existing environment very nicely working very good. God, believe me. I mean, you know big data, you play big data, you know that the pace, the speed of innovation is just so fast. It will just happens all the time, things coming out, and then the old things or the one you're using right now, yes, still nice and good, but you will definitely want to try that new tool, and then it might gonna really help you something, and then even to make things easier. I mean, come on, if you can achieve exactly the same thing, exactly the same result, why don't you try something easier? Right? Just make your life easier. Getting more coffee, getting more cakes, instead of like spending your time do that codings, right? And other than that, you might want to start to think about how to scale, how to analyze the data in a scalable ways, and then even to build some streaming data pipelines, and even having the machine learnings into your application and your service and apply it on those data you have. All right, so what we're going to do here is we will talk about some of the cases. For example, we will talk about product recommendation using Cloud SQL and Spark. And of course, what is a Spark? You might know, you might not know. So Spark is a big data open source framework, and it's quite famous already here in the industry. And that's a big data open source. You can use it everywhere. I mean, it's an open source. But I will say it's really good that you can run here on Google Cloud Data Proc. And I'm going to show you how to get that ready and then really run something. And I'll say for Cloud SQL, actually, we have mentioned that in our different sessions already. That's for storage. And that's a great place to store those recommendation results and then get it back to the users. And other than that, we will talk about how to classify returning customers with a BigQuery machine learning. Wow. So we will actually tell you what is a BigQuery and how cool it is. I mean, that's something really amazed me and almost let me lose my job before, actually, because that's something, it's a killer, really. And I'm going to show you how BigQuery make things happen, and then also you will be so amazed, even just I show you something, and then later on something even bigger, which is that you can do machine learning with BigQuery. So we will do that. And then we'll have the real-time dashboard with the pops up data flow, Data Studio, and that's the streaming part, and I'll share a story with that. And classifying image with ML, which is, machine learning. There's two ways that we can use those pre-built models, and then you will see something also just amazing again. Oh my God, I'm using so many words about amazing, but it is amazing. So which is Cloud Auto ML, and that's the one I will do demos for you. Okay, so now let's see what else we do. Yes, we do need to talk about the infrastructure from a data standpoint. So let's see. First, coming back to our Google's mission, what we're trying to do all the time, I mean, as the entire Google, not just Google Cloud, we want to organize the world's information and make it universally accessible and useful. And so for us to support that, yes, the foundation is actually security. And then on top of that, compute, storage, networking, and the big data machine learning products. So instead of just look at the slides, let's do a quick demo.
My name is Meenal Borkar and I work as a Google trainer for Cloud Team.
So in this demo, we will take a quick walkthrough of Google Cloud Console. Now, the first question is, how can one reach to Google Cloud Console? So one need to follow the link console.cloud.google.com, and then you need to log in using your Gmail ID or your company ID. Once you log in, you will see a welcome page for Google Cloud Platform, which is popularly known as Web Console. Now, there are multiple ways to interact with Google Cloud Platform, and one popularly used is Web Console. So let me zoom in a bit. So here the first question is, where can you see different products and services which are being offered? So for that purpose, we need to go to navigation menu. And in this navigation menu, we will basically click on and see different categories. So there is a compute category, there is storage category. So basically products and services are categorized under different labels. Another way of launching different services is you can search through it. So say for example, I want to search for BigQuery. So I will just type the service name in the search bar, and then I can launch the service. Now, one important thing one should know is, in order to start any product or any service, you should be part of something called as project. Now, project is basically a mechanism through which resource utilization and billing is monitored for a particular customer, for a particular user. So you can see currently I'm part of GCP training project which I have created, and you can easily create project by clicking on the drop down list and then by clicking on this new project option. Now you can see multiple projects are created here, and depending on which class, which training I'm delivering, I typically select a suitable project for me. Now on your web console, you typically see multiple cards like these. So the first card that is of useful or that is useful for us is project info. Now typically a project is identified with three things: project name, project ID, and project number. Now project name, this is a human readable entity and you can change it anytime by going to project settings. Project ID, this is an immutable entity, but while you create your project, you may give project ID, but afterwards you cannot change it. Project number is internally generated and you cannot change it either. Now, next important card is this resources card, and it will basically list different assets which are created under my project. So as of now, you can see in my storage area, I have created 3 data locations in which data is available. Now, if in my project virtual machines might have run, then those virtual machines would have also been listed in this resources card. Another important card is this billing card, and as the name suggests, it gives us idea about estimated charges for the upcoming or the current month. If you want to see the details of billings, service wise, product wise, consumption wise, you may always click on detailed charges and you may check it further. As we are just beginning our journey, important card is this getting started card. It gives you list of multiple tutorials which you would certainly like to go and practice hands-on. So do make sure that you have all these links present. If you are interested in going to more detailed documentation, then documentation card is also part of our web console. Now this layout is perfectly customizable, and you may click on customize button to arrange different layouts. Now it is also possible to interact with your Google Cloud platform using command line instructions, and Cloud Shell will be that environment using which a terminal can be launched and you can start interacting using commands or using instructions on that terminal. If you want to see various activities which are happening inside your project, click on this bell icon and you can see different activities which were done previously. For any type of help, do click on this help icon, and that is all. So this was a very quick go through of Google Cloud Platform Web Console, and let us go back to presentation to cover next part from the agenda.
Wow. So let's see compute. So take our examples here. We said machine learning models, they require a lot of computing resource. And just take this one as examples. We have a feature called video stabilizations. For our Google Photos, if you ever use it before, that's something really nice, because even you have a little bit shaky hands like myself to taking some videos, it's okay, because when you're taking some photo, maybe you're laughing, maybe you're just having some fun. Yeah, it's okay, because we will have that feature to help you with it. And then for that, to make the left-hand side video to become the very stable one on the right-hand side. Wow. What kinds of data source we have? We have image frame, we have photo, gyroscope, and then the lens motions. That's a lot of things. And then just to look at it, with this single high resolution image, it richly actually presents millions of data points to actually learn. Wow, that's 8 megapixel resolutions, and that's around like 23 Oh, wow. That's a million. 23 million data points per image. Wow, that's a lot of things. And then, you know what? For Google Photo and YouTube, we both need to work on those kind of things every single day. And believe me or not, Google Photo, how many photos we have per day? You want to guess? Google Photo? We have around billion users, so we actually have 1.2 billion photos and video upload to Google Photo every single day. And that's around like a 10 petabyte of photos. And for YouTube, we have 400 hours of video uploaded every single minute. Wow, that's a 60 petabyte of data within an hour. Wow, that's a lot of things. And that's the size we need to process. So you see, that's a lot. So we said Google train on its infrastructure and deploy those machine learning to phone hardware. So what we do, we can't really just do every single thing. We also leverage some computing power from you, actually. You know what? So we actually having those data coming here, and then we do the training. Once we're done, we will actually have that model goes to your phone, which is the app you install, and then just give you that nice experience to use that feature there in your mobile. So that's something what we done. And of course, that's what we do. But then what about like you, if you wanted to leverage those kind of nice things that we have? Of course, still the same. Processing, training, prediction, those kind of things, a lot of computing. Yes, you can rely on us. You can use our Google AI things or those pre-trained AI building blocks, and that's super nice. And we will talk about it today, of course. And we said build on Google infrastructure, and this is what makes Google Google, because even for us, we build things on top of something else, which is we make it or we have them available internally. So we said that's the model of all clouds. And here, it's one of the statements, something very important that our head of AI, Jeff Dean, have mentioned, that if everyone spoke to their phone for 3 minutes, and then we will exhaust all available computing resource. This is just something, you see, even at Google, even at the scale that we have those huge amount of computing resource, that's still gonna happen. Just spend 3 minutes, everyone at the same time, boom, Google crash. Oh my God. And is this one the Moore's law going to save us? Basically, it's not, because it actually hits the physical limits already. And so what we do this one. We go for a TensorFlow processing unit, which is specialized in machine learning, and the version 1. So the version 1 is actually focused on what? It's not training itself, it's actually predictions, because a lot of customers coming to us ask for the API result, and then so we do that first. Okay, so now here, it's one of the examples coming from our customers. This is actually eBay. So what they do, they actually leverage our TPUs to faster their model creations. What they're trying to do is actually they wanted to recognize those items. And then if the customer asks them, hey, I wanted to looking for this one, for example, a shoes. And then that specific shoes, is it available here in eBay? I'll say, yeah, I don't know. But then ask our model. So eBay actually create a model for that. So that's something very nicely, because they need to create a huge model. And believe me or not, that model is not easy. Why? Because you actually need to do the training again and again. Why is that? Very simple. Because they are a platform, and those items are not actually from them. They're actually from some other providers to put on their platform. So they always need to go and check and do the training again, and then to map to those places, right? So that's kind of the case. So the model is actually, they need to keep retraining. So this one, the TPU give them 10 times the speed. So let's do a quick demo.
We are going to see how a virtual machine can be created and then how we can, work with that machine. Now, we all know that the compute engine service, which we are going to use here to launch that virtual machine, is listed in navigation menu. And if you scroll down to compute section, compute engine service is listed here. So what is a virtual machine? So basically it is a virtual CPU that we are going to create. Now, being a infrastructure as a service offering, you can actually specify all the hardware specification about your machine here. So let us click on create. Now, what all things we can give here? First one is instance name. So let me give name as demo VM. Then by using region and zone, we specify in which geographic area, in which data center you want this machine to come up. So I will not change the default settings. I will say, okay, launch this machine in US Central 1, which is Iowa region, and this zone looks fine to me. In the machine configuration, you can specify what kind of capacity, what kind of hardware configuration you want this machine to have. Now, if you are hosting balanced workload or average workload, general purpose machine families are suitable for you. If you are working with memory intensive workloads, then memory optimized machines are required. And for CPU intensive workloads, basically compute intensive options or compute optimized options are suitable. Now mine is demo 1, so I will simply go with general purpose machine, and then I can select the series, and even I will go with first generation machine, and then I get customizations in the range of 1 virtual CPU to 96 virtual CPU. I will simply select 2 virtual CPU as my configuration. So as a result, I am going to get 2 virtual CPUs with 7.5 gigabytes of memory. And you can see the family, CPU platform and family that I am getting here. Now, if you want to change the operating system with which this machine to boot up, you should really consider visiting this boot disk section where my mouse is currently hovering, and you may change the operating system which you would like to install. By default, it will give us Debian Linux 10, which is recently default setup here. Another important section is how exactly you want this virtual machine to interact with other services on Google Cloud Platform. And that access pattern, that access scope, we can specify with this setting, identity and API access. I want this machine to interact with all GCP services, so I will allow full access to the cloud APIs. Other firewall and other stuff, if you want to set up these settings, they are available here. Another important thing which I wanted to show you, depending on the configuration which I have selected here, a monthly estimate is also generated here on the screen. So if you change your machine type, this estimate will change. Now, if you remember in my first demo, I mentioned like there are multiple ways using which you can interact with Google Cloud Platform and you can launch different resources. So using Web UI is one way. If you want to launch similar virtual machine using API call, then this REST link, you can see it here at the bottom of the screen where my mouse is currently pointing. If you click on it, it will give you a REST template which will launch equivalent machine using API call. If you want to create this machine by using command line instruction, then here is the template that you should consider using. So I will just click on create here. Typically, compute engine service takes 90 seconds to provision the virtual machine to us, and you can see the machine is currently coming up, and in the bell icon you can see the activity was happening here. Now see, the machine is up and running. By default, your virtual machine will come up with 2 IP addresses, internal IP. So these are RFC 1918 addresses, and there is an external IP using which you can also reach out to this machine. Now, if you want to install some additional software component on this virtual machine, because this is infrastructure as a service provisioning, so you can install whatever you like, then just SSH into this machine and then install the components, and then just continue working with it just like a normal machine. So let me show you installation of Git software here, just to give you a reference. So I'm clicking on SSH. Now this has opened a new window here, and we will get a thoroughly established SSH session to work with. So let's wait for SSH window to open up. Alright, so let me zoom in a bit. Now I want to install Git, so I will say sudo apt-get install Git. Yes, I want to install it. And then it is pretty much the same Linux based machine which you can use to work with further things. So that was a quick demo of how you can create your virtual machine and how things go further. So let us go back to our presentation deck and then understand next fundamental service, that is storage.
Wow. For storage wise, I mean, you guys know that's the size already for Google Photo and for YouTube. So in this case, how are you going to do that? Well, of course, use cloud storage. Cloud storage is designed for 11 nines. Oh man, because there's so many nines, I just want to say 9, right? 99.999, there's 11 nines. And that's the design for durabilities. So storage, put on cloud storage, and that's the easy and nice place to keep any kind of binary files, okay? So image, audio, that kind of thing is good. So other than that, in Google, we also have a lot of different kind of storage options. You can go for it. So that's nice. And then this is one of the options. So let's do a quick demo.
In this demo, we will be working with Google Cloud Storage, which is the storage or service on GCP. So I'm going to navigation menu. I'll scroll through and reach out to storage section, and then I'll select the second service, storage, which says browser. I'll just click on it. Now, as we discussed, all your data is stored under something called as a logical handle called as bucket. So let us create a bucket here. Now the first parameter that we are required to provide here is globally unique name. Now why name has to be globally unique? Because it is a flat file system, and all the buckets, all the storage logical handles, they will be available at same location. So that is the reason we need a globally unique bucket name. Now, how can we make sure this is globally unique? So if you remember, our project ID is typically globally unique. So create a bucket with your project ID as a part of it in order to avoid the clashes. So let me create a demo bucket with my project ID. So I'll just use it. Okay, so see, it is unique here. Now, whenever you are creating a bucket, you should be really very sure about where exactly you want to store your data. Now, if say for example you are a business and your business data is expected to be accessed say within India or within Europe or within any other US region, then create a regional bucket. If you are looking for higher availability and you want to access your data across 2 regions, then dual region setting is there. And if you want to get highest availability across largest area that you can cover, then multi-region will help us. Now mine is just a demo one, so I will simply create a regional bucket, and in the location I can then specify where exactly I want this bucket to be created. So you have Americas region, you have Europe region, you have Asia Pacific regions. Now for this demo bucket, I will simply go with US Central 1 region, and I'll click on continue. Now, next important is what is the purpose with which you are creating this bucket and you're storing the data. So, if you are storing hot data and you want to access it frequently, standard class is really recommended for you. If you are creating this bucket for backups, then nearline is the storage class. If you want to use this as disaster recovery, then cold line class will help you. And if you are just keeping your data for long-term digital preservation, then archive class is suitable. Now, depending on which class you are using, your monthly cost estimate, which you can see here on the right hand side, will change. So let me show you a sample here. Suppose I'm going to store 500 GB of data and I'm using standard class, then you can see my monthly cost is around $10. Now, if I change my class to nearline, see the monthly cost has changed to $5. Further, with cold line, it is just $2, and with archive, it is just 60 cents. So this is how the pricing estimator will also give you idea about how much you should expect in terms of costing. So I'll just go with standard class. I'll close this monthly estimate and then I'll simply click on continue. Now, as we are going to store data inside this bucket, we are very curious to know how exactly we are going to control access to these objects. So by default, fine-grained access to different objects is recommended, but you can also provide uniform access if it is really required. I'll go with fine-grained, click on continue. Under additional settings, you may specify encryption, whether you want to go with Google Managed Encryption, you want to go with Customer Managed Encryption, do you want to set up any retention policy, do you want to provide any additional metadata, etc. With this bucket. I'll not change any settings here, I'll simply click on create. Now the bucket will be created, you can see the bucket is created and currently it is empty. So let us try first uploading some sample files. So I'll simply click on upload file. So there are multiple ways you can upload it. I'm just using web UI way. So firstly, I'll just upload a sample file. Say for example, this one. And see the upload is complete and the file is immediately displayed here. Next, let me create a folder called as SQL, and inside this folder then let me upload some more files. So I'll click on upload files, I'll go to downloads and then I will simply search for SQL accommodation, SQL ratings, and SQL table creation, these three files. And I'll just click on open. I have uploaded 3 files. You can also copy and copy different files, and you may create folder by using a gsutil command by using your Cloud Shell. That is also possible. So now one thing which we want to see, that for every file you can see what is the size of the file, what is the type, when is it created, what was the storage class, and what kind of access this file is having, which encryption it is using. Now let us do one thing. Let us change some of the permissions to our file. So I'm just using this JPG file and I will try to change the access permission. Now for this, I will simply click on these 3 dots and then I'll go to edit permissions. Now, when you click on add entry, you can basically add a user to get access to this data file, or you may add a domain, you may add a Google group, you may add a project, or even you can make it public. So firstly, I'll add it for a specific user. So I'll say that this file should be available to this user and can get only reader access, and I will save it. So this is one way. Another thing which I wanted to show you, we can also give public access. So let us do one thing. Again, we'll go to three dots, click on edit permission, and then add entry, and in the drop down select public. So by default you may say all users will get a reading permission, or you may also say all authenticated users to get some permission here. I'll simply say all users to get reader permission. You can also assign owner permission, but that is risky. So going with reader is good. Click on save, and then you see a URL is available using which this file can be accessed. So this is a way using which you can work with different files in your bucket, and you may work with their access settings. So that was all about demo. So let us go back to our presentation deck and let us start talking about our next fundamental service in the agenda.
Wow. Now what about the networking? So networking here, yes, with Google have those private network carry as much as 40% of the world's internet traffic every day. So we actually need to build a lot of things to serve our customer, those under the sea fiber cables, and then they are shark proven as well, and we need them. And the other thing, it's actually happen right there in the data center, which is not goes to you, but actually happens in there in the data center. Why is that? Because nowadays, we actually need to separate the compute and storage to have a decoupled system to able to scale nicely. We said scaling, very important. So here, even for us, yes, scaling very important for storage and compute. So those two need to easily to scale. So in this case, we separate them. We have decoupled systems so we can easily scale. But at the same time, that means we need to transfer the data to get the data to the compute and then start to do the processings. And for that one, yes, you need to transfer, then you need some time. But here we have this one called 1 petabit per second of total bisection bandwidth. That's really the game changer here that make things, we are able to separate them, and then you don't get the penalty of the performance, okay? And of course, other than that, still the subsea cables, okay, the fiber cables, that's the one we still have, and that explained to the globe. All right, so other than all those things, of course, still we have the security, and on Prime you manage everything, but now if you do on cloud, Google basically help you to manage a lot of them, but still, just as a reminder, yes, you still need to take the shared responsibility to taking care of that. All right, so that's still very important. Okay, so now we have seen those foundations, which is the infrastructure about compute, storage, networking, and the securities. Let's see what are those big data and ML products. So we Google here, of course, we know that we need some new data processing methods as we grow. And back into 20 years ago, when Google started, yeah, still again, the Google search story. Google search, we crowd all the data coming from the network, and then what's the first challenge to do is not just crowding them, but actually to save all the data. Because without saving them, we cannot process them. So just imagine how many data are there in the entire internet? Petabyte? No. 10 times? 100 times? Okay, you do the search. We have Google search for you. You will get the answer, of course. Yeah, so that's a lot, and you need some ways. And that's 20 years ago, and we need a solution for that. So we invent something called Google File System, and when we even publish them as a paper to share to the world how we actually make that happen. Able to taking care that huge amount of data, which is a distributed file system, able to scale out on the fly. Anytime we need more space, we just scale it out. And at the same time, we need to process them in time. We have MapReduce coming up, and then we even need to do the search such a small amount of time for every single user. I mean, every time you click, it's a sub-second query. Wow. And how many users doing that at the same time? whole bunch of them. So you see that's hard. So you see these are actually all the name of the papers and then they all published. And what's next? Google Cloud just bring up all those innovations as infrastructures for you, okay? And that's just nice, so nice, because all kind of things we have here, all the technologies, just bring it to you, and then you can easily to leverage them. So we have a whole bunch of different products for Google Cloud Platform for storage, ingestion, analytics, machine learning, and even for servings. And let's see what you can do with Google Cloud Platforms. I mean, give you some cool reasons that what kind of things that our customer or some people they have done already. So this one. So Keller Williams, they actually use Auto ML Vision. Okay, you will see this one today. Automatically recognize common elements of a house or furnishing and architectures. Yeah, because you know that, I mean, furnitures, there's a small little pieces, a lot of those small little pieces. And it's very hard for you to understand what is that small pieces. And then you always need to recognize them. And then it's quite a common thing that your customer come to say, hey, I bought something. And then that's the small little broken pieces. Can you give me a spare one? And then you're like, let me go and check what is that. All right, and then they might not even know what is that kind of the specific numbers for checking that small items. But here, now we have an Auto ML Vision, and then the machine, they can just memorize so many things, especially for those very tiny little details. So this will be a good one and a good fit. And another one is Ocado. So Ocado is an online grocery shopping website, and then they have so many feedback coming from their users because they deliver around like 1 million things to customers every single day, and then every delivery, of course, they want some feedback coming from users. But I mean, you have the time to read 1 million emails every day? I don't think so. So what they're trying to do, they were going to capture those information, and they first make sure to go to the related departments, and then maybe they'll find some people to read some of them, or just get what is the majority, what's the kind of the focus that people wanted to talk about. Is it about the pricing? Is it about the delivery? Or is it about the service itself? All right. So that's one of the things, because this way you can scale. All right. As a data engineer, very important. As a data engineer, you need to make things happen in productions, because data scientists, they do the crazy ideas, and then you'll be the one to make things happen. Seriously. Okay, so if you're doing things, make things in production, you are the data engineer, no matter what your title right now. All right, so this one will be nice, because you can rely on API, and then that just scales everything. And here, QB, oh my God, that's nice. That's one of the food providers, and they provide some baby food, and they wanted to sort out those bad potatoes. And before, they just used human to check it out, and now they have a model. All right, so now there's one thing you can do, actually. I mean, I'll say you just do it afterwards, but I'll just show you. So we actually have a place which is cloud.google.com/customers. And that's the place we have a whole bunch of those use cases. And you might going to see something very similar to your case. And then there's some existing solutions for it already. So that'll be something nice. But then before you go and check, let me just share you something. This is something happens here. Okay, this is actually in Indonesia and also in Singapore as well. It's Gojek. They are one of our customers, and they really bring goods and service over 2 million families in 50 cities in Indonesia. And this is their footprint. Basically, it's nationwide. Wow, that's a lot. And what kind of things they do? Wow, you see, go ride, go car, go food. Oh my God, that's nice. Okay, I'm a little bit hungry right now. Okay, I'll do that later. And then even massage as well. I mean, whatever. They have a whole bunch of service, and then they manage 5 terabyte plus data every single day and have to analyze them. So they actually face the scale problem and the latency challenge as well. And they do migrate their data pipeline to GCP. So this is their architecture. They have pub/sub data for BigQuery, which is the step that will introduce them later, which is for streaming. And the challenge is this one. The business question is which location have mismatched supply and demand in real time, because they deliver things, everything deliver. So they need to know where's the customer, where's the driver. So the challenge here, what they basically pin every one of their drivers every 10 seconds to make sure where they are, to know that, okay, those are the people to help us to deliver things to our customers. So they need to make sure they have kind of the balance, okay, having the balance. So, which means 6 million pings per minute and 8 billion pings per day. Oh my God, wow. I don't know, that's that big. So how do we actually stream and report those things with that such values? Okay, so we will tell you later on how to do that, but basically what they actually achieve is using this one called auto-scaling streaming pipeline with Cloud Data Flow, because Cloud Data Flow is the one designed and really focus on taking care of streaming kind of jobs. So this one really taking care the auto scaling to taking care of those up and down kind of loadings, because you never know what's the timing people are hungry, they wanted to get some food, or you just know that some people start to want some massage, and then the demand for the driver to ship you somewhere, right? So those are the things you don't know. So you need to taking care of that streaming kind of changing loadings. And then this is the visualizations of their demand. Wow. This is cool. You see those green or red kind of dots? Yes, that's the one. And then you can even see that huge red zones. That means that's the hot zones, okay? That's the hot zones. So that's the kind of things they will be able to achieve, and this is the real-time dashboard for them to actually tell that the driver, all right, now that's the place. A lot demand, need more drivers. Please go these directions. All right, so far that's for our first module to talk about the introduction of Google Cloud Platform. Now you know what's the compute, what's the storage, what's the network, and what kind of things you can do with our customer cases. And even one of the really cool cases here happens in Indonesia. And now, thank you for joining our digital event. Please stay tuned for our next module.